See, I have taken this example in the previous video, so I am going to take this example only for explaining the deletion operation. If you get how to delete data from a specific position, then you can easily get how to delete data from beginning and how to delete data from end of the array. Fine. So first of all, we will discuss the delete process with the help of this example, then we will write down the code. Fine, and also we will discuss the time complexity. See, here I have taken these lines from the previous code only, from the previous video, that I have declared one array of size 50. So these bits from 100 to 299 would be allocated, 200 bytes would be allocated by the memory manager for this array, one variable size. Fine, this is the maximum size, but actually suppose the user wants to insert only 10 elements, 5 elements, then we will ask from the user how much size he wants for the array. So we will ask enter the size of the array and the user will enter the size. So for the size also 4 bytes would be allocated somewhere in the memory. Suppose here I am taking the position at the address 304, and then we will ask from the user for the elements of the array. We are going to initialize the array at runtime. So enter the elements of array. For entering the elements, loop would be started from 0 to size. Size is suppose 5. Here I am taking array in which size is 5. So loop would be from 0 to 4 because array index would be started from 0, and we are going to populate the array like this. Fine. I have discussed this coding in the previous video in detail, so you can check out that video. See, now suppose user has entered this data in the array. Now you will ask the user from which position he wants to delete the data. And now see, suppose he said I want to delete the data from position 2, right? So position 2 means from this position. Index is 1. I am taking index and position, different thing. Index is 1, but position is what? 1, 2, second position. So from this position I want to delete the data. This 2 I want to delete. So simply if you delete this 2, so now what you will do, you cannot shift 6 here because this space you cannot leave it blank. But one thing you can do, you can shift 10 this side, 4 this side and 5 this side. That would be fine. And after shifting these elements, the size would be decreased by 1. So after deleting this data, size would become 4, right? Now size is 5. So we are going to shift this 10 this side, this 4 this side and 5 to this location, right? So we are going to start a loop. How you can do this? See, here we have 2. So we are going to start a loop from here. Suppose I am going to take a variable I would be started from this one. From which index? Position minus 1. I would be started from position minus 1 because position is 2, so I value is 1, right? Till position minus 1 to here till 4, or you can say size minus 1. Size is 5, so here till 4, or you can say till 3. Why till 3? I will tell you. See, now we are going to shift. I would be started from here, so now we are going to shift this value here. So here what you can write, this value of this array of 2 would be shifted to array of 1. So you can say I plus 1 to I, right? So we have shifted this 10 here. Now again we shift this, I would be incremented by 1 now, I is this one now. Now we'll shift 3 value at index 3 to 2. So 4 would be shifted to here. So here we will write 4. Fine. 10 would be overwritten. 10 is no more now. Again we are going to shift now, I would be incremented, I is at this place. Now this 5 would be, I plus 1 value would be shifted to I value. 5 would be shifted here. So here you will write 5. So now simply you can say, you can delete this one, or you can say now size becomes size minus 1. So you just do size minus minus. See, I am going to process the loop, I am going to run the loop till 3, not till 4. Because when I is equal to 3, then simply we write what? This a of I plus 1, that is 4, would be shifted to a of I, that is 3, here only. So no need to increment this I here. We are going to run the loop from here till here only, till size minus 1. That is fine. Fine. So this is now the updated array. And if you want to print which data you have deleted, so what you can see, before shifting this these values, you can write down what you can take this value and you can store this value to somewhere. You can say you can take one variable that is item and you can store here 2, and after that you can print this. If you simply want to delete, then no need to store this 2 value here. You simply start a for loop and start shifting these values. Start a for loop from position -1. So now we will write down code for this. See here, size we have taken, array of size initially we have taken 5. After deletion it becomes 4. So now you will ask from the user from which position you want to delete the data. Fine, and user will enter its position. So you will write. So this is how we are going to ask from the user. So you are going to take a variable that is pos for position, for storing the position. Fine, because obviously when user will enter the data for position, then that value would be stored in memory, and how value would be stored in memory using variables. Fine. So see, now you also check. See, now if position is -1, if user entered -1, then what happens? Then obviously there is no index of -1, na? So we will also check the position should be a valid position. And if user enter position is equal to 48, so now at 48 we don't have any data. Fine, so this is also invalid position. We have data from 0 to 4th index only. Before deletion the data was from 0 to 4. So you can enter from 0 to 4, the position would be valid. So you will also write down if statement to check the validity of this position. If position is less than equal to 0 or position is greater than size, right, then it becomes, you will print invalid position. See here I am taking position would be started from 1, that is why this is position 1, so that is why I am taking position should be greater than 0, that is position would be started from 1, right, and position should be less than size. Size is 5, so 1, 2, 3, 4, 5, this is the valid position only, right, because if you give 6, then at 6 we don't have any data, right. And you will also check if there is no data in this array, then obviously that is underflow condition and you cannot delete the data. Else you will write, now for loop would be started. Now we are going to delete. See, suppose position is this one, so position is 2, user has entered a value 2 for this, from this position you want to delete. So from this position only you are going to shift this to this, then this value to this, you are going to shift something like this. So we are going to start a loop from I is equal to position -1, position is 2, so loop would be started from 1, I is equal to 1 now, and I should be less than size -1 minus I plus plus. Why I less than size -1? See, size we have taken 5 at starting, and we are going to run this I for loop till 3. So till 3 means size -1, size -1 is 4, so I should be less than 4, that is till 3 we are going to run. You can run this for loop till 4, that is also fine, but obviously that would increase the time taken for computing for this for loop only. Fine, so that is of no use. So now in this case you will write what? So now here you will write the a of I plus 1 value would be shifted to a of I. When I is equal to position -1, that is position -1, that is 1, I is equal to 1. So value of this 1 plus 1, that is 2, a value of 2 would be transferred to value at 1. That is exactly we have done. Fine. And now what you will do? Now you have done your shifting till this. So now you will write size minus because size has been decremented by 1 now, right? And now at last you can print the array. I guess you can print the array. Updated array is just write down a for loop from I is equal to 0 to size less than size. Now size is 4. After size minus, this size becomes 4, right? This value becomes now 4. So from 0 to 3 value would be printed. I is less than size, and in for loop you can write printf %d a of I. This is how we are going to delete the data. And one more thing I have told you in the previous video also, that in arrays, when we are discussing arrays in C, then there is no concept of bound checking. It means, suppose you have declared array of size 50, and if here you will enter the size of array is 60, and if you start entering the data, you can easily enter 60 elements, but that is not possible, because that should not be possible, right? Because at starting, how much space has been allocated for 50 elements only, for this only, from 100 to this 200 bytes. So how can you store 60 elements once you have declared, and as we have read that array size is fixed. Once you have declared the size, you cannot change the size, right? So this is now you have to check, the programmer have to write a code to check the boundaries of the array. So after this, after entering the size, you can write down one if statement. If size is greater than this maximum size, greater than 50, then you can print out of bound. And in else block, you can write further, enter the elements in this for loop, right? And after that, you can print the updated array. See here, no need to store this element in anywhere, because we just want to delete the data. So just shifting would be enough. If you want to print which data you have deleted from the array, then you can store before this for loop, you can write item. Suppose you will take one variable where you will store the value, so you can write item is equal to a of position minus 1. Position minus 1, that is a of 1. A of 1 is 2. 2 would be stored in this item, right? And after that, you can print the value deleted is, and you can print, you can say like print %d and item you can print. So if you take this case, here also you are going to declare a variable item, fine. But if you don't want to print the value, you can simply ignore this one and simply write down this for loop. So if you want to delete the data from the end of the array, then that is very easy. No shifting would be done. No need to ask for the position. No need to write down this for loop. Just to size minus minus, right? Fine. And if you want to print, then you can store this value in item and you can print that value, fine. And if you want to delete from the beginning, then what you will do? If you want to delete this 6, then from the beginning only you are going to start the for loop for I, and all the values would be shifted here, left side. So you are going to start this for loop from I. So updated for loop from, if you want to delete from the beginning, then the updated for loop would be for I is equal to 0. I would be started from 0 only, and I should go less than size minus 1, same, and I plus plus, and simply write down this thing only, a of I and I plus 1, and after that size minus minus, fine, because we are going to start from this position only, na. We know the fixed position is you are going to delete the data from 0th index. So start from the 0 only. So if you talk about the time taken, the time complexity, then here also the time complexity depends on the position from where you want to delete the data. If you want to delete the data from this position, then you are going to shift all the elements n, theta n. If you want to delete from end, then obviously theta 1. So it depends on the position, as we have discussed in insertion case. So theta n minus p you can write. But simple logic is, see, this is unsorted array, so ordering of these elements doesn't matter here. So rather than shifting, we can do what? The very quick algorithm is what? If suppose you want to delete data from this position, position 2. So simply what you can do, you can pick the last data from the array and you can put this data here only, right? And you can do size minus minus, and size would be from 0 to 3. So this is now our array, and that's deletion. So it will take constant time, that is theta 1, order of 1 you can say. But if array is sorted, in that case this ordering of the elements would matter. In that case you cannot do this thing, you can directly, in that case you can't pick directly the last element and place at the position from where you want to delete the data, because it will disturb the order of the elements in sorted array. In sorted array it is must to use this process, the shifting process, but in unsorted array you can do this thing. So the best algo will take how much time? Theta 1, or you can say order of 1. But the condition is this array should be unsorted. Here we are taking what? Linear array, or you can say 1D array, that is unsorted. In that case the best algo would take constant time to delete the data from any position, from the beginning, from any specific position, or from the end. So now I am going to start the topic linked list from the next video. So I will see you in the next video. Till then, bye, take care.